Senhoras e senhores participantes, é uma honra apresentar nossa palestrante principal para o 20º Seminanosoma, a doutora Inele Malsch, diretora da Malsch Techno-Valuation, situada na Holanda. A doutora Malsch é uma renomada especialista no campo da nanotecnologia e suas implicações éticas, e temos o privilégio de tê-la aqui para ministrar a conferência de abertura. Seu extenso trabalho se concentra na avaliação da nanossegurança, um aspecto crítico do cenário em constante evolução da nanotecnologia. Com um profundo compromisso com o desenvolvimento responsável desse campo, a doutora Malsch nos guiará por uma discussão instigante sobre as dimensões éticas de compartilhar ou não compartilhar dados de nanossegurança. Suas perspectivas prometem lançar luz sobre o equilíbrio essencial entre o avanço científico e o gerenciamento responsável na era da nanotecnologia, preparando o terreno para as discussões subsequentes de nosso seminário. Em sua carreira distinta, a doutora Malsch fez contribuições significativas para o diálogo em torno da nanotecnologia, ética e segurança. À medida em que abarcamos nessa jornada de exploração durante o 20º Seminanosoma, antecipamos que suas perspectivas fornecerão as bases para as discussões multidisciplinares que se seguirão. Informo que, para promover a melhor acessibilidade possível de nosso evento, a doutora Inele Malsch gentilmente gravou a sua conferência para que pudéssemos inserir legendas, mas ela encontra-se presente entre nós ao vivo, por meio de videoconferência, e, ao final de sua fala, estará ansiosa para responder a questões e fomentar o debate. Gostaríamos, mais de uma vez, de expressar nossa gratidão à Universidade Federal do Espírito Santo, UFES, à Coordenação de Aperfeiçoamento de Pessoal de Nível Superior, CAPES, ao Conselho Nacional de Desenvolvimento Científico e Tecnológico, CNPq, à Fundação Jorge Duprá Figueiredo de Segurança e Medicina do Trabalho, Fundacentro, e ao Conselho Regional de Engenharia e Agronomia do Espírito Santo, CREA-ES, pelos valiosos auspícios concedidos para a realização dos nossos eventos. Passando a palavra para a professora Inele. Professora, thank you very much for your gracious accepting our invitation and gracing us with your presence, as well as your generously sharing your time and expertise.
Thank you for morning. I would like to talk to you about assessing ethical impact of sharing nanosafety data or of not sharing nanosafety data. After a brief introduction, I will explain a bit about the ethical impact assessment methodology I use. Then on the issues I identified, how it was evaluated on the framework of ethical theories, and also to stimulate some discussion about draft recommendations for remediating possible negative consequences. Yes, there is a sort of international movement for stimulating the open publication of research data, and this is stimulated both by governments and by researchers. It can be any kind of data from any kind of research, but in my presentation I focus on data on environmental health and safety issues, and in particular about nanomaterials. In our studies we found that decisions of sharing nanosafety data or of not sharing nanosafety data after research raise ethical issues, and we identified and analyzed these issues and drafted recommendations for how to remediate possible negative consequences using online ethical impact assessment tools. So this is a screenshot of our website where we posted the ethical impact assessment tools. These tools are, they're based on a procedure which was not invented by me, so we adapted standard published by the European Standardization Organization CEN, and that's called CEN Workshop Agreement on Ethical Impact Assessment, which was developed in the European funded Satori project. In our project RISCON, we adapted or applied these ethical impact assessment procedures to the case of nanomaterials and nanomaterials used in products, and also to develop online tools to help a user pass through the different stages of this ethical impact assessment procedure. So the methodology, this process consists of 6 steps. You start by a threshold analysis. This can be a project coordinator of a project where nanomaterials are developed or applied. And coordinator basically uses a tool to make a self-assessment of foreseen ethical impact. And this is used to determine the need for and scope of the ethical impact assessment. Then, if the issues identified are severe enough or are significant, a plan has to be made of the resources needed, which methodologies you will use, and how you engage with stakeholders to identify and analyze the ethical issues. And basically, using desk research, you identify ethical issues by taking a bit more in-depth analysis of the issues, also trying to compare it with studies known in the literature. Then you evaluate the identified ethical issues with the help of philosophical ethical theories, but you could also engage stakeholders to make sure that your assessment of the severity of ethical issues is also shared by others, especially by people who are working in the field or are, who have to deal with the consequences of the, in this case, the publication of nanosafety data. Then in the end, it's not just an academic exercise. You really draft some recommendations to remediate possible negative consequences, but then it's very important to also discuss these draft recommendations with stakeholders. And finally, to make sure that that the quality of the ethical impact assessment you performed is good, you have to ask an external ethicist to review the whole procedure and the outcome. So I applied our online ethical impact assessment tools on this case study of whether or not nanosafety data should be published online openly. And for screening, I used a checklist of 9 categories of negative ethical impacts: health-related issues, privacy issues, liberties, impact on equality, on the common good, on the environment, on sustainability, and on military dual use and issues. And we, using this checklist, which is very, very general, allowed to determine the scope of full-scale ethical impact assessment, and it helped select which ethical impacts were deemed relevant to decision-making on whether and how to share nanosafety data. And we estimated the severity of each issue on a 5-point scale. And the tool helps to sort of identify or advise on which kind of ethical impact assessment you have to do. So it's either no ethical impact assessment or a small, medium, or large-scale ethical impact assessment. And a small-scale ethical impact assessment will be appropriate. So then we used a more detailed checklists to identify in literature possible ethical issues, and also to make an estimate of the severity of each issue. Then, well, we performed the analysis both for the case when data was shared and when data was not shared. Both could raise ethical issues. And in my estimate, the overall severity of not sharing nanosafety data tends to be stronger, but the balance between impacts of sharing or not sharing nanosafety data can differ in a particular case. And of course, it's my expert estimation of the severity of each case, so this estimation of the strength of each impact is open to discussion. Yeah, so sort of guide this making an estimate of how severe each issue is. I used a 5-point scale, like I said. So basically, well, 6 because 0. You can also think that this issue is not applicable in this case, like for instance in military dual use. So the nanomaterial of nanoproduct has no effect on this ethical issue. So then it's not no. But if you do think there is an issue, then it can be minor, and that which means that effects are very unlikely or have very low potential strength. You could, for instance, think about the frequency of this ethical impact is less than once in 100 years, or only a few people are likely to be affected temporarily and reversibly, or the new technology does not significantly worsen or improve ethical impacts caused by existing alternatives. Then when you think it's more than minor, perhaps it could be moderate. The effects are unlikely and or have mild potential strength. An example could be that the impact may happen a few times in a lifetime, or a few people are likely to be affected mildly for a long time or irreversibly, or many people are likely to be affected temporarily and reversibly, or the new technology noticeably worsens or improves ethical impacts caused by existing alternatives. So it's always a relative scale. And well, it's more than that, so effects could be medium. And then the effects are substantially likely or have substantial potential strength. For example, the ethical impact is expected to occur several times in a lifetime, or at least a few people are likely to be affected substantially for a long time or irreversibly, or the new technology substantially worsens or improves ethical impacts caused by existing alternatives. And if you think it's even more than that, then it could be strong. So the effects are likely or have high potential strength. This ethical impact will occur frequently, or many people are likely to be affected strongly for a long time or irreversibly, or the new technology seriously worsens or improves ethical impacts of existing alternatives. And if you think that it's even more than that, then the effects are very likely or have very high potential strength. For example, the high ethical impact occurs permanently. Many people are affected strongly and irreversibly, or fundamental human rights are violated, or large-scale impacts on the society and the environment are expected. Okay, so that's about the benchmark. And then if I sort of looked at the literature on sharing safety data or comparable cases, then I found that not sharing the data raises strong effects on the equal distribution of risks and hazards. That would be a 4 of the 5-point scale. And the main reason is that there are existing inequalities in health, so workers and consumers who are exposed to nanomaterials can have negative health effects, and so they are more at risk than people who are, for instance, managers or who are not exposed to the nanomaterials. And these health inequalities can be reduced if sound nanosafety data are used to improve the regulation to protect their health. The question is basically, so my estimate is that this is very strong, so it has a strong effect on the equal distribution of risks and hazards. But you could think that it's less severe or even more severe. Then not sharing nanosafety data. So then there are also two issues which I think are medium severely. And so if you don't share nanosafety data, this could have medium effects on limiting the health risks of nanomaterials, because the disclosing such information is closely linked to the right to know, and this is one of the basic human rights defined by the United Nations. So it has a clear effect on basic human rights, which I base on a report by UNEP. And the effects are substantially likely and have substantial potential strength. And data sharing substantially improves the ethical impacts caused by existing publication practices. So it really just openly sharing nanosafety data can help a lot in limiting the health risks of nanomaterials. Also, well-being and interests of individuals and groups in society, including quality of work, has a medium effect, and also replicating and building upon existing research. Because if you regulators undelayed access to sound nanosafety data, you can help them to come to a conclusion on evidence-based regulation of nanomaterials sooner. And so the effects are substantially likely, and at least a few people are likely to be affected substantially for a long time. And data sharing substantially improves the ethical issues compared by existing publication practices. So it has a medium effect on the well-being and interests of individuals and groups. And not sharing the nanosafety data could raise moderate effects, so that's 2 on the 5-point scale. On the limiting of environmental impacts of nanomaterials. It delays the emergence of in silico risk assessment and extends the use of animal testing. So I based that on literature I found. And I estimate that these effects have mild potential strength because data sharing noticeably improves the ethical impacts caused by existing publication practices. Not sharing nanosafety data moderately delays achievements of the Sustainable Development Goal 12, which is the achievement of the sound management of chemicals throughout their life cycle, so that by the year 2020, so that's 3 years ago, chemicals are produced and used in ways that minimize significant adverse impact on the environment and human health. It has not quite been reached. But if you share the nanosafety data, you could contribute to achieving this goal. I think the effects have mild potential strength because data sharing noticeably improves the ethical impacts by existing publication practices. And imposing restrictions on sharing nanosafety data which could be misused by others may negatively affect academic freedom. I think the ethical impacts are minor because they have very low potential strength. Only few people are likely to be affected temporarily and reversibly. Data sharing does not significantly improve the ethical impacts caused by existing publication practices. So the issue is, and you share the data sooner or later or more extensively, it doesn't really matter. Sharing nanosafety data raises moderate impacts, so that's the other, the reverse of the issue. So now we do share nanosafety data, but it also can have moderate impacts on intellectual property rights, where researchers in resource-poor settings are nudged into sharing hard-won nanosafety data. I think the effects have mild potential strength because on the one hand, data sharing noticeably worsens the ethical impacts posed by existing publication practices, where results can be shared in academic literature without access to all research data. And then the scientists producing the data have more time for further analysis of their proprietary data. This is especially in the interest of researchers who have less resources to do their research. On the other hand, sharing nanosafety data raises moderate impacts on social justice and equality, especially because the distribution of economic resources to do the research may be unbalanced. And this can be more severe if it's not clear who pays for the open access. So researchers in resource-poor settings could be disadvantaged if they are forced to share their research data they collected slower and with less advanced equipment than peers in better resourced labs. But the effects have mild potential strength, and many disadvantaged researchers are likely to be affected temporarily and reversibly. Then I foresee moderate dual-use impacts. Some nanosafety data could be misused for biological or chemical weapons, and the effects are unlikely under current nanosafety research practices. And it not only depends on the public availability of the data, but also on the presence of educated experts with harmful intentions. Then at the same time, people misinterpret insufficiently verified nanosafety data. This could contribute to environmental health and safety risks, and it could be used to support false claims. But I think the effects are unlikely if people misinterpret data in good faith. So it's possible to tell them and convince them to make the correction. But the risks could be more severe if the data are intentionally misinterpreted. On the other hand, it's not likely to significantly worsen the ethical impacts caused by existing publication practices. So it's a problem which already exists, but sharing the nanosafety data does not have a very strong effect on that. On the other hand, a significant societal risk is that the cost of sharing nanosafety data will prevent societally useful science from being done. So basically, you can only spend your euro or real once. So if you have to spend more time and resources on sharing nanosafety data, you can't put it in new research. And so then, after sort of making this inventory of expected ethical issues, both of sharing and of not sharing nanosafety data, it's now time to make the analysis to evaluate the ethical issues. And in this core part of this ethical evaluation is to balance trade-offs between the different ethical principles which are at stake. If you decide to share nanosafety data or not to share it. And it's also important to take remediation measures to reduce the negative ethical impacts of the decision to share or not share nanosafety data. So if you look at it, assuming that you want to share nanosafety data, then this could have negative effect on intellectual property, on social justice, on dual use, and on animal ethics. But on the other hand, it can have benefits for public health, environmental ethics, and animal ethics. So you can also try to improve the benefits and by taking remediary action to counter some of the expected risks. So one of the trade-offs which are identified is that the interest of public health can sort of collide with protecting social justice. So to make sure that people in disadvantaged researchers have the same opportunity as more resourced researchers. And then Bezuidenhout made recommendations to address binds of place between better and less resourced scientists in the open data discourse. And she recommends to not just discuss the data, but also to discuss the laboratory equipment and research speed, to include all the aspects of the research environment where people have to do their work, and also to engage scientists in lower middle income countries. So make sure that they're involved in the decision making, and also to adopt frugal or responsible design principles in future open data initiatives. So this is a matter for discussion. Are you agreeing with this recommendation? Do you think it makes sense, or do you think it will not help? And another trade-off is between publishing open data and concerns for possible dual use aspects of the published data. Then Bezuidenhout and Morrison recommend to not just look at it as very black box issues, but to balance the responsibilities for open data and dual use. Also, not only addressing the responsibility of scientists, but also of governments, of other actors in society who can also contribute to preventing dual use and fostering open data, and also to focus more on the everyday practices of laboratory scientists to sort of make sure that prevention of misuse or is more integrated in the practice, and less focus on abstract conceptions of what is data. So do you think that will help, or is it not good enough? I would like to know your views. And the third recommendation is addressing the management of research organizations. They could raise the awareness of research integrity principles and train researchers in best practices in their organization. So this, of course, research integrity is broader, but it also helps to make sure that the quality of the data is better, and so that what you share is actually useful in society. If you are a researcher or a manager of a nanosafety research organization and you collaborate with researchers in developing countries and also with freelance researchers, it's recommended to implement the Trust Code, which is a global code of conduct for equitable research partnerships, with 4 main principles, so fairness, respect, care, and honesty. And these principles are then also subdivided in very practical recommendations for what to do in each context and how to make sure that also the researchers in developing countries benefit from the research collaboration. And then the 5th one is more focused on those research projects where animals are used. Of course, we all know that researchers using animal tests should comply with the 3 R's: reduce, refine, and replace. And in this case, it can be important to replace animal testing not only with in vitro methods, which are more common, but also to new methods like in silico methods. So this is a recommendation which could be valid for some researchers working with or producing nanosafety data. So thank you for your attention, and I look forward to discussing with you.
Thank you, Dr. Inele Malsch. I'm glad to host you here online, and I will kindly ask you to speak in Portuguese a little bit to promote the participants to interact with you, okay? Então, convidamos agora toda a plateia para direcionar questões, dúvidas e observações à doutora Inele Malsch. Dentro do possível, eu vou traduzir. Para aqueles que não falarem inglês, se quiserem fazer suas perguntas em português, eu posso ajudar nessa tradução e falar com ela. Tá bom? Se for alguma coisa técnica, com certeza eu teria uns colegas aqui para me ajudar.
Pessoal, a gente está com o microfone aqui. Quem quiser fazer uma pergunta, a Patrícia já disse, pode fazer em português, ela faz a interação. Esse tema está diretamente conectado com a nossa discussão ontem, né, sobre os dados, sobre os experimentos e quem faz, quem divulga, quem é responsável em relação à segurança de trabalhadores, entre outras coisas. Essa é a grande temática. O Paulo está aqui disponível para começar a provocar o debate. Vou passar a palavra para ele. Paulo.
Paulo vai falar em inglês ou em português?
Eu falo a pergunta em inglês para ela e depois eu traduzo aqui para...
Então você faz a pergunta em inglês e você mesmo traduz para português, está ótimo.
Dear Inele, thank you so much for your contribution with our seminar. Was very well, but I would like to see your opinion about another slogan. Do you know the slogan that no dates, no market? I propose another slogan, no ethic, no market. What is your opinion? Eu perguntei sobre, existe um slogan na Europa que é sem dados, sem mercado. E eu estou propondo para ela opinar sobre um novo slogan, sem ética, sem mercado. Ok, your answer, please.
Thank you, Paulo, for this intriguing question. Yes, I think as an educated ethicist, of course, I am always in favor of everybody thinking and reflecting about ethics. But I think ethics is not the solution for everything. So you can't say, okay, we were thinking about ethics and now we don't have to use legislation to protect our citizens. So ethics is, I think it's broader than just legislation because you can also consider ethical considerations at a time when there's still uncertainty about possible risks for health and for the environment. But in the end, you do need to go to Parliament and adopt firm legislation to protect citizens and to also give clarity to companies wishing to bring new products and materials on the market, what is allowed and what is not allowed. So I do think that ethics is important, but it's not the solution for everything.
Bom, ela concorda que a ética é importante, em resumo, ela concorda que a ética é importante, mas não se resume só à ética. Ela continua valorizando bastante a questão dos dados. Algum complemento, professor? Algum complemento, professor? Bom, esse é o resumo da resposta dela. Bom, agora mais algum outro comentário da plateia? Plateia participativa?
Eu acho que vocês vão ter a possibilidade de fazer perguntas agora e depois vai aparecer um QR Code aí para vocês responder as questões que ela colocou na apresentação dela. Então, é uma dupla possibilidade de participar com uma pesquisadora importante aí dessa questão da nanotecnologia e dar a opinião que ela está buscando de pessoas que não são especialistas, não é? Como é o caso de vocês. Então, quem se habilita aí? Se não, eu faço uma segunda pergunta.
Patrícia, eu vou fazer a pergunta e você faz a tradução. Good morning, Dr. Neck. Sou o Jorge. Eu gostaria de entender, ontem nós tivemos uma discussão nesse seminário sobre exatamente a geração de dados sobre toxicidade.
Só um pouquinho, Jorge. Okay. Yesterday we had a discussion about data in toxicidade.
Yeah.
Nanotoxicidade, ok?
E a grande dúvida, né, que a plateia colocou é sobre de quem é a responsabilidade pela geração de dados.
Okay, and the big doubt that it was debated yesterday was who is responsible for generating the data.
E no caso brasileiro, a gente discutiu a questão da responsabilidade das empresas e a gente gostaria de saber qual é a realidade da Europa.
And here in Brazil, the responsible are the companies, the industries, and we would like to hear from you what's the perspective in Europe.
That's it.
That's it. That's the question.
Okay, thank you. Yes, in Europe we have the REACH regulation, so that's broad in general regulation for giving rules for companies who want to bring chemicals, substances on the market, and they have to do tests for toxicity and for safety of the materials, and then submit the data to the regulators, to the European Chemicals Agency.
Just a minute.
And so, yeah.
Ok, então na Europa a regulamentação ela está bem clara, tá? Por várias classes, entre elas para empresas e por tipos de materiais. Go ahead, please.
Okay. So in Europe also the company who wants to bring the product on the market is responsible for testing and for sending the data to the regulators, and then the regulators have to allow the material on the market or refuse it.
Ok, então as empresas enviam os dados para os órgãos reguladores e eles sim analisam e depois publicam esses dados. Ok?
Yes?
Respondido, Jorge? Ok? Thank you. Good answer. Alguma outra pergunta? Plateia? Só quem está em pé que fez pergunta até agora, né? There is one more question there.
Patrícia, a Aline pergunta em relação à Europa de quem é a responsabilidade por fazer a fiscalização. No caso brasileiro, a Arline chamou a atenção ontem, o Ministério do Trabalho, mas a gente sabe que o Ministério do Trabalho é um órgão ainda insuficiente em termos de tamanho para fazer toda essa fiscalização nas diversas áreas, né, porque não é só toxicidade. E no caso da Europa, existe um órgão equivalente ao Ministério do Trabalho? Como funciona a fiscalização? Ou é autorregulação? Como é que funciona lá?
Okay, the question is, here in Brazil, it's asking for a comparison again. In Brazil, the Ministry of Work, alguém me ajuda? Como é que é fiscalizar em inglês? checks, evaluate, okay? The minister, there is a unity or entity that analyze what's going on with the industries, okay? So that's a ministry for that. And in the other hand, they would like to know how it works, who or which is the entity who would make this job to analyze, to check how it's going, how it happens in Europe.
Okay, so it's not a ministry in Europe, it is an agency. So it is a government organization, but it's not part of the government. And it's called the European Chemicals Agency, ECHA. And they are responsible for verifying the submissions of the companies and for deciding on whether the material is allowed on the market, whether it's only restricted to certain applications, or whether it's not allowed on the market.
Ok, então ela disse que não é do Ministério, e sim uma agência, que ela deu o nome, que tem essa responsabilidade de verificar e acompanhar como é que isso acontece na Europa. Tá? Não está dentro do Ministério. Respondeu? Oh, ok. Ela não sabe como é que é o brasileiro, né? Okay, so does this agency does the agency make their job well? Is it good how it happens in Europe?
Well, nothing's perfect also in Europe, but I think most of the time the companies submit data and do good quality research. And also you have academics who do independent testing, or national institutes for doing health and public health research. They can also do independent testing of materials. So it's not just that we believe the companies on their blue eyes. There are checks and balances in that too. But quite regularly we do have scandals where companies, for instance, now there's a recent scandal where companies had submitted data to the United States FDA and not to the European agencies. So it's important to keep vigilant and also to check what companies do and whether it's honest and fair.
In a Brazilian way, I would translate it is like, are there complaints about this agency?
Well, I think in the general public, as far as people know, the European Chemicals Agency, I think they have quite a good reputation. So they're not, I mean, there's always complaints, but I don't think there are very serious issues against them.
Ok, thank you. Então, ela disse que pela população sempre há algum tipo de reclamação. Por outro lado, eles têm uma boa reputação e as empresas confiam nas respostas que eles dão, no serviço deles.
To add that, in the chat I put the website of the European Chemicals Agency, and they also have the information in Portuguese, so you can check for yourself what data there is and what information there is about what they do.
Inele, Paulo Martins again. You speak very quickly about right to know. So I would like to have your comments if the normal citizen in Europe use the right to know in relationship to the nano products or the nano research, to know more things about this process of the production, the nano products, or how the research is doing in Europe, and with the right to know, the people can or not can have some informations about this. What is your opinion?
Vamos traduzir primeiro?
Eu perguntei, ela falou sobre uma legislação que existe na Europa que se chama direito de saber, não é? Right to know, direito de saber. Então, eu estou perguntando a ela se ela avalia que os cidadãos comuns da Europa, né, usa essa legislação para saber mais coisas sobre os produtos nanotecnológicos ou sobre as pesquisas que se fazem sobre nanotecnologia. Ok, né? Answer.
Thank you. Yes, that's a good question. I think maybe around 2010 there was more public debate about nanotechnology, and so people were probably also more aware about that nanomaterials were actually used in products, and were looking for information about what is in it and is it safe, and are the implications for our health, for instance. And now I think the average citizen may not be so aware, but on the other hand, many products like cosmetics, for instance, if there is a nano material inside, it has to be on the package. But not in all kinds of products, but in certain categories of products, labeling is obligatory. So that helps if people really want to know that they can find out that nanotechnology is actually inside the product. But I think, but it's very difficult to have more discussion about nanotechnology in public. I don't know about Brazil, but I think many people have different concerns, and also some NGOs which were working on nanotechnology now are sort of thinking that they have different priorities and are not putting so much time and effort in studying where nanotechnology is used and what it means for citizens. Is there any recent discussion, public discussion in Brazil about nanotechnology, or is it the same as here, that it's more quiet now?
Ok. Ela informa que os cidadãos europeus estão mudando também o conceito e boa parte das informações também já estão vindo nas embalagens de produtos e o comportamento das pessoas vem mudando. Então, uma das funções dela e das entidades é fazer com que essas informações estejam cada vez mais disponíveis e que haja motivação dos cidadãos pela busca dessas informações. Tá? Ela também questiona as pessoas aqui presentes de como é que isso está no Brasil hoje em dia.
Patrícia, eu vou fazer uma última pergunta para a gente fechar o debate. A doutora Inele tem uma pesquisa que ela quer que a plateia participe, a gente vai projetar o QR Code já já. A minha pergunta, doutora Inele, é em relação à regulação das novas tecnologias, ou de maneira geral de tecnologias na Europa, que a gente vai ter já uma discussão sobre regulação e autorregulação, a nossa próxima mesa, se ela acredita, não, como ela vê a questão da autorregulação do uso de tecnologias ou novas tecnologias na indústria europeia, se acha que funciona, qual é a visão dela sobre a autorregulação.
Um momento. So, this will be the last question here. Dr. Malsch, And Jorge asks you, what's your opinion about the auto-regulation for the incoming or the new nanotechnology? É isso, Jorge? Mais alguma? Qual é a... Só...
Se ela acha que funciona, que tem funcionado.
So does it work? Is it working? The new ones will work? So this would be the good questions for the next section that we'll have here, that will be about auto-regulation in the new or the incoming nanotechnology. How does it work?
Yes, so in Europe, the interest of regulators and researchers in nanosafety is sort of moving more to advanced materials in general, but then nanomaterials are a very important part of that. And also the question is less going to have more regulation, but more towards have safe and sustainable materials by design. So actually not just do the risk analysis tests of the material when it's ready for entering the market, but from the beginning of developing a new material, which can be a nanomaterial, but which can also be another advanced material, to make sure that the design of the material takes into account possible risks and is designed in such a way to be safe for humans and for the environment. And of course, that is still a sort of aim for the long term. So we can't be sure that it's actually, with every material, it's safe. So you still need to test it. But this helps to sort of improve the safety of the society and the environment against new upcoming materials.
Okay.
So that is the focus of the discussion in Europe, but also at the Organization for Economic Cooperation and Development, OECD, which is sort of developing global standards for nanosafety and now more and more for advanced safety of advanced materials.
Ok, thank you. A resposta dela, Jorge e demais participantes, é que a preocupação hoje com a regulação e a autorregulação encontra-se em fase, prioritariamente, na fase de design dos produtos, na fase de projeto dos produtos, que é a fase que é melhor compreendido e que você consegue colocar as questões de padrão para ambientes internacionais. Então, ali, se você estabelece quem está desenvolvendo propriamente, você garante o melhor uso do produto, conscientização e adaptação da população que vai usar o produto lá no final do seu ciclo de vida. Então, a função delas de autorregulação está concentrado na parte do projeto do produto, do design lá do processo.
Perfeito. Patrícia, a gente vai encaminhar para o encerramento da mesa. A gente gostaria de informar, Patrícia vai informar, sobre a pesquisa da doutora. Ela gostaria que todos participassem. Vocês que estão aqui presentes, a gente vai projetar o QR Code. Patrícia vai dar os encaminhamentos.
Bom, a pedido da doutora Inele Malsch, disponibilizamos em nosso telão um QR Code para que a plateia possa responder a uma pesquisa sobre o tema aqui discutido. Pedimos a gentileza da participação de toda a plateia. Aproveitamos para agradecer toda a gentileza e generosidade da doutora Inele por sua participação em nosso seminário. On behalf of our audience and organizing committee, we would like to extend our heartfelt gratitude for your enlightening lecture and the engaging discourse it ignited. Your insights have enriched our event in a meaningful way, and we truly appreciate your valuable contribution. Warm regards, and sorry for my translation.
Thank you.
And also,
the translation was very clear, so I also thank you for inviting me to talk to you, and I wish you a very good continuation of your conference, and maybe until next time.
Okay, thank you. At this moment, they project the QR code, and in a few minutes you have the answers. Okay? Thank you very much once again. See you.
Thank you.
Stefano, projeta para a gente, por favor. Perfeito, obrigado. Está aí, é só ler o QR Code, participar da pesquisa. Enquanto isso, a gente vai organizar a segunda mesa, a primeira.